This is question 1. It's a question involving r cos x plus alpha, and as usual with these questions, I think it's best not to try and do a shortcut. The way I do this is to do the expand these brackets first using the addition formulae, which is in your formula book. If you expand that, you should get cos x cos alpha, and then that would be minus sine x sine alpha. Then I'd stick the r back in, so you've got an r there, you've got an r there, and you'd also have an r there. In this question, we have got we've got a 7 cos x minus 2 sine x. So just try and match these up now. This cos x is the same as this cos x, which means that r cos alpha must equal 7. So I'll write that down. R cos alpha equals 7. Let's use a different color for this side. If we look at this side, we've got the sine x here and the sine x here, which means that r sine alpha is going to equal 2. I'll put that on top. R sine alpha equals 2. And then if we divide these, these are two simultaneous equations. There's lots of ways of solving these two simultaneous equations. I would just divide them, and then you get tan alpha equals 2/7, and then you can just use inverse tan on your calculator. We need to be in radians here by the looks of it, so make sure your calculator is in radians. If you do inverse tan of 2/7 on your calculator, you'll get 0.278 and so on, but it's 0.278 to 3 significant figures. To find r, you could just substitute that back into one of the two equations, but r will always equal r squared will always equal this squared plus this squared. The reason for that is due to sine squared plus cos squared equaling 1. If I just quickly show you, if we square the top equation, we get this. If we square the bottom equation, we get this, and so that will equal 2 squared plus 7 squared. And if we take out the r squared here, we've got sine squared alpha plus cos squared alpha equals 2 squared plus 7 squared. So in other words, since this will all equal 1, this equals 1 here, that means that r squared will equal 2 squared plus 7 squared. So anyway, we didn't really need to do that. R is going to be 4 plus 49, so r squared is 53, which means r is a square root of 53. And so we should probably just write the answer as root 53 cos x plus 0.278. Part B looks a bit of a strange one. It's saying a sequence of two transformations which maps sec x onto this curve here. So it looks a bit of a strange question, but as usual with A-level maths, one thing to look out for is if ever part B of a question looks difficult, then have a think have a think and see if part A is going to help you out. In this case, it will do, I think, because you can write y as 1 over root 53 cos x plus 0.278. In fact, with all of these are cos x plus alpha or are sin x plus alpha questions, you're always going to need to use what you did in part A for part B or possibly part C. So how does this help us out? Well, this can now be split up into 1 over root 53, and then 1 over cos is sec, so this is sec x plus 0.278. So if we start with the curve y equals sec x, and we want to transform it onto this graph, well, you can see there's the two transformations we're going to need. It doesn't matter which order you do these two transformations. If we do a stretch in the y direction by a scale factor 1 over 53, that will get the curve to look like this. So the first transformation, call it number 1, is a stretch in y direction by a scale factor 1 over root 53. So that's the first transformation, and then you can see here we now need to transform this x to this. So that's going to be a translation to the left by 0.278. So we now want to get this to look like this, x plus 0.278, and so our final transformation is a translation in the negative x direction, 0.278. Easiest way to write that is probably as a vector, so we can write it as minus 0.278 and 0. So those are our two transformations. Just to reiterate, the order you do these two transformations doesn't matter. You will still get, you'll still go from here to here. So you can have these in either order